So this is problem 515, and for A, you must find the initial angular momentum of the system about the axis through P. So angular momentum is just L equals the sum of mv cross r, and v equals rw, so you just plug that in, and then you get L equals mr squared omega. And now you just plug in the variables that they give you. The first weight is 2m, and that is 1 L away, so that's L squared. And then you have the omega initial. And then added is the smaller weight m multiplied by 2L because it is 2L distance away, and then omega. And you just combine those two and you get 6 ml squared omega. And for B, you must find the frictional torque acting on the system about the axis, and you just use the equation torque equals F cross R, and F, you know, is equal to the kinetic friction of each of the weights added together, so it's the sum of those. So you just put those variables in that they give you, because N equals mg, so you have the first weight, which is 2 mass times the coefficient times gravity times 1 length away, plus the second weight, smaller weight, the coefficient times 1 mass times the gravity constant times 2L away, and you add that together, and that equals 4 mu mgf. But because it is an opposing force, the force will be negative. And for C, you must find the time at which the system will come to rest because of the kinetic friction. And you just set up T equals I alpha, and you know L equals IW. That's an equation. So you set your L that you found beforehand, set that to IW, and then you find I, and you use the equation that you had before right here. You set your torque equal to the I that you just found times alpha to find alpha. That will give you angular acceleration. And now you just use a kinematic equation instead in terms of angular perspective, and through that you can find time by just setting omega to 0, omega final to 0. You're given omega initial, and you plug in your alpha that you're given multiplied by t, and you solve for t. That's all.